In this video, we're going to look at how to solve systems of equations. There are many different methods that you can use. The first method that we're going to review is the method of equal values. You will want to use the method of equal values when you notice the two equations are both solved for the same variable, in this case, y. Since both of these equations equal y, I can set them equal to each other. From there, that gives me one equation with one variable that I know how to solve. I subtract 2x from both sides. That leaves me with 4x plus 7 equals 11. Subtracting 7 from both sides leaves me with 4x equal to 4. And then solving from there gives me x equals 1. Okay, this is a system. I need to figure out where these two lines meet. I need an x and a y coordinate. So I'm going to go back to either one of these two equations. I'll pick this one and plug in x equals 1. I get 2 plus 11, which gives me a value of 13 for y. If I were to write that as an ordered pair, the solution for those two lines is 1, 13. That means these two lines will meet at the coordinate 1, 13. The second method that we're going to look at is called substitution. You want to use substitution when one of the equations is solved for one of the variables. In this equation, I know that y equals negative 3x plus 5, so I'm going to put this in y's place in the other equation. So copying the equation, I'm going to write 5x minus 4, and then instead of y, I'm going to put in the negative 3x plus 5. And then the rest of the equation stays the same. From there, I distribute. And I have one equation in one variable that I know how to solve. I'm going to combine like terms, then isolate the variable by moving the 20. And my last step is to get that all completely by itself, divide both sides by 17, and I get x equals 1. Again, I need to go back to my top equations and plug x into one of these equations. This equation is much easier than the second one because it already has y by itself. So I'm going to choose that equation off to the side here. And using that first equation, I'm going to write y equals negative 3x plus 5. But instead of x, I'm going to write it with the 1. Negative 3 times 1 plus 5. I get y equals 2. So the coordinate 1, 2 is where these two lines meet. The third method that we're going to show is how to use elimination. When you're using elimination, you want to look for coefficients that are exact opposites of each other. I have that here in negative 4x and 4x, so that tells me this is a good candidate for elimination. So what I'm going to do then, since those are set up to cancel already, I'm just going to go ahead and add these two equations together. I get negative 4x plus 4x gives me 0x. Those are gone. Negative 2y plus 8y is 6y. Negative 12 plus negative 24 is negative 36. Gives me a one-step equation with one variable that I know how to solve, resulting in y equals negative 6. Now I need to plug that y value back into one of these original equations. I'm going to choose the bottom one because it has less negatives in it. So I'm going to say 4x plus 8 times negative 6 equals negative 24. One equation with one variable that I know how to solve. 4x minus 48 equals negative 24. Add 48 to both sides. I get 4x equals 24. And then when I divide by 4, I'm going to find that my x value is 6. So combining these two, I have an ordered pair value of 6, -6, which means that my original two lines up here cross at the coordinate 6, -6. I want to look at another elimination problem because they're not all set up where they're exact opposites of each other. In this case, when I look at the y's, I notice that they're the exact same as each other. So what I'm going to do is I'm going to multiply one of the equations by a -1. So I think what I'm going to do is multiply this first one by -1. So that becomes a positive 2x minus 2y equals -14 when I multiply everything by -1. I'm going to copy the other one over just to line it up nice and neat. Okay, now I have numbers that are exact opposites of each other right here. I have a plus 2y and a minus 2y, so I'm good to go to combine them. When I combine them, 2x plus -8x gives me a -6x. The y's zero out, and I'm left with a -6 over here. When I divide by -6, I get an answer of x equals 1. I'm going to take that and plug it back into any one of the original equations. I'll use the very first one. Just copied that right here. And now I'm going to plug in that 1. So -2 times 1 plus 2y equals 14, which gives me -2. And then I'm going to add 2 to both sides, giving me 2y equals 16. And then when I divide by 2, I get a result of 8 for my y value, meaning the coordinate where these two lines intersect is 1, 8.